All right, geometry, OST review, topic 3 on transformations. Again, the state test loves transformations. They do. They'll ask several questions about them. So in topic 3, we learned 3 transformations. The first one were reflections. So reflections are where you kind of flip across a line. So in this picture here, line M is the line of reflection. We're flipping triangle ABC across that line. Again, one of the important things to remember is that the reflection line is the perpendicular bisector between your pre-image and your image. So if you connect B, the pre-image, to B prime, the image, if you connect them, this line of reflection should go perpendicularly through that segment, and the distance between the pre-image and the line should be the same as the distance between the image and the line. Okay. Now there are some rules on the coordinate plane. The one rule I would try to remember is when you reflect across the line y equals x. So if you remember on a coordinate plane, the line y equals x goes right through there, through the origin. So if you have a point like right here, say that point is the point 1, 3. When you reflect it across the line there, the x and y just switch to 3, 1. So when you reflect across the line y equals x of any point x comma y, it just becomes the point y comma x. Okay, so you might want to memorize that rule for the state test. Next we have translations. Translations are pretty basic. You just got to remember that if they give you the translation in like this form, so remember that it is the x movement first and the y movement second. So that first number, you're going to go left to right, and that second number, you go up or down. Okay, don't need to worry about this right here. Okay, next we have rotations. So rotations are probably the most difficult, right? They're hard to see. Just remember about rotations that when you do rotate, the angle formed by the pre-image, the center of rotation, and the image should be that angle of rotation. And it is typically counterclockwise unless they note differently. Okay? Again, you want to know this. So there were 3 rules that we used on the coordinate plane. So if I'm going to rotate by some angle counterclockwise, right? That's an angle symbol counterclockwise. And the original point was xy. Well, if I go 90 degrees counterclockwise, that's going to be 1 quadrant turn. So the y comes first, and it becomes opposite of what it was. And the x comes second and stays what it was. If you do 180, that's going to be 2 quadrant turn. So the x and y flip back. So the x goes back first, but now it becomes opposite. And the y goes back second, but it stays opposite of what it was to begin with. Right? So opposite of x, opposite of y. And then if you go 270, that's going to be 3 quadrants this way. So 3 quadrants this way, or you can go 1 quadrant clockwise if you want to. Right? You can go 90 clockwise. Because 270 counterclockwise is the same as 90 clockwise. That gets you 360 together. And here what's going to happen is your x and y will flip. So your y will come first, but it will stay the same, and your x will go second, and it becomes opposite. So put that opposite symbol in front of that x, opposite of x. So there are your rules. You might want to memorize these rules. It might be easier for you on the state test with rotations. Okay, and then lesson 3-4 kind of put all these together. A lot of times we did what were called compositions of transformations. So compositions are where you do 2 or more together, right? Now, the key here is that we're doing rigid motions. Rigid motions make sure that the pre-image and the image are congruent, right? These are all congruent transformations, okay? And if I were you, what I would do is I would focus on one pair of corresponding vertices when you're doing problems like this. So say you had to like figure out, I don't know, what transformation gets you from, you know, A to A prime, right? Or from ABC to A prime, B prime, C prime. Focus on A to B, or sorry, A to A prime. What change happened there? And then once that's verified, then do a second one. Then do B and B prime. And if that still holds true, then I bet you that is the transformation that you have to use. Okay, so again, go vertex by vertex. That's my suggestion. And then last but not least are the symmetries, right? They like symmetry. To me, symmetry is a basic concept, but they do like it. So there are 2 types of symmetry. There's reflectional symmetry that involves lines of reflection. And again, you're looking for the line to reflect onto itself. So this airplane here, if you draw this line right down the middle, right, and you were to reflect one side or the other, it would like fold onto itself, right? Or if you reflected it, it would just kind of flip and stay the same shape. Okay. And then you have rotational symmetry, which means typically it's used the center of the figure, right? And you rotate it about itself, and you want it to land on itself, right? Map onto itself by rotation. So if we take this point, this tip of the point right here, right, and we rotate it 90 degrees this way, now this tip lands on this tip, and everything turns, and it's good. Now if we take this and go 180 degrees, now this tip comes down here, again, still lands on itself. That's still rotational symmetry. If we go 270, excuse me, the tip lands here, so that still is going to rotate onto itself. That's 270 degree rotation. And if you go all the way around back to 360, you become back onto yourself. But that doesn't count. We don't count 360. So this has 3 rotational symmetries, 90, 180, and 270. Remember that if your figure is regular, so for instance, an equilateral triangle, all the sides are congruent, all the angles are congruent, it's going to have 3 lines of symmetry, and it'll have 2 rotational symmetries, but you really do 360 divided by 3 to get those increments. And that'd be 120, then it'd be 240, and then again, it's not 360, so it'd be 120 and 240. So regular figures have very nice symmetries. All right, and that's topic 3 review.